Into this, the very first thing which will come, that is the law of chemical combination, right? So put a heading, law of chemical combination. Okay, law of chemical combination. Now, what does it mean? So whenever reactants react together, right? Means when the substances which are reacting to form some new substance, right? So the substances which are reacting are called reactants, right? So whenever reactants react together to form the products or the elements, right, combine together to form a compound, right? And they do this according to certain laws. Is that clear? And these laws are called laws of chemical combination. Is that clear? Right? So please write. So, so what does it mean? It means that whenever there is some reaction, right? So there are some substances, right, which are reacting together, and these substances are called reactants. Getting that? Some elements are reacting together, so these are called reactants, right? And they combine to form some compound or element, right? Or the molecule, right? So they are doing this according to some law. Is that clear? Right? So they are following some law while doing this, right? So this is called laws of chemical combination. Is that clear? Right? So a scientist, Antony L. Lavoisier, right, laid the foundation of chemical sciences by establishing two important laws of chemical combination. Right? Now, what are these laws of chemical combination? So the first law in this is law of conservation of mass. Law of conservation of mass. Now, what is it? Right? So this is the first law under law of chemical combination, that is law of conservation of mass. As the name indicates, according to this law, mass can neither be created nor be destroyed. Right? As we have law of conservation of energy, right? Similarly, we have law of conservation of mass. Means mass can neither be created nor be destroyed during a chemical reaction. It means that in any chemical reaction, the total mass of the reactants, right? Okay, so total mass of the reaction, this plus this, right? So the total mass of the reactants is always equal to the total mass of the product, right? And there is no change in the mass during the chemical reaction. Is that clear? So what this law says, it says that mass can neither be created nor be destroyed. However, whenever the reactants are reacting, right, their masses, the total mass of the reactant is always equal to the total mass of the products. And this law is called law of conservation of mass. So now you can write down. It states that mass can neither be created nor be destroyed. Okay? During a chemical reaction. During a chemical reaction. Okay? That means in any chemical reaction, for any chemical reaction, total mass of reactants, total mass of reactants. Reactants means which are reacting, is always equal to total mass of products. Is that clear? So what is the law of conservation of mass? That total mass of reactants is always equal to total mass of products. Right? That means there is no change in the mass during a chemical reaction. Is that clear? And this is called law of conservation of mass. Now, on the basis of this, let's see this question. Question number 1. If 4.0 gram of sodium carbonate reacts with 10 gram of hydrochloric acid, it results in the formation of 2.5 gram of carbon dioxide and 11.5 gram of sodium chloride solution. Show that these results are in accordance with the law of conservation of mass. So we have to show that this is This is according to law of conservation of mass, right? Is that clear? So what is given here? That sodium carbonate, while reacting with hydrochloric acid, right? Sodium carbonate, how much? This is 4 gram. React with hydrochloric acid, that is 10 gram. It gives carbon dioxide and sodium chloride, right? This is 2.5 gram and this is 11.5 gram, right? This is the equation, right? Now let's see what is the total mass of the reactant. Total mass of reactants. Reactants means which are reacting, right? These are the compounds which are reacting, right? So these are reactants, right? So what is the total mass? 4 gram plus 10 gram, yes or no, right? So 4.0 plus 10, that is 14 gram. This is the total mass of reactants. Now let's find out the total mass of products. Products means the compounds which are formed, carbon dioxide and NaCl. The mass is 2.5 gram plus 11.5 gram. Add them. So you're getting 14 gram, right? So as you can see here, that total mass of reactants is equal to total mass of products. They are same. Yes or no? 14 gram and 14 gram. Getting that? So yes, means they are following the law of conservation of mass and there is no loss or gain of mass after the reaction. Is that clear? So in this way, we can say that whenever a chemical reaction taking place, so there is a law of conservation of mass. So I hope you're getting this. Yes, sir. Please note down. Now, look at the second law of chemical combination, and that is the law of constant proportions or law of definite proportion. Right? This is the second law of chemical combination. First law is law of conservation of mass, and now the second law is law of constant proportion or law of definite proportion. Now, according to this law, in a chemical substance or a compound, the elements are always present in definite proportion. Here, proportion means ratio, right? They always present in some definite ratio by mass. Is that clear? That means in a compound, such as, for example, if we talk about the water, H2O, right? So the ratio of the mass of hydrogen to the mass of oxygen is always 1:8. Is that clear? So they always, in which proportion they are combining? 1:8, right? So whatever the source of water, right? If 9 gram of water is suppose decomposed, right? Suppose you have a 9 gram of water and you are decomposing it, right? So what you will get? 1 gram of hydrogen and 8 gram of oxygen, right? This will obtained, right? And they always combine. These elements are always present in this definite proportion, that is 1:8, right? Similarly, if we talk about the carbon dioxide, right? Carbon dioxide always contain carbon and oxygen, right? And now the ratio of carbon and oxygen into this is 3:8, right? 3:8. That means if you have 36 gram of carbon dioxide, right, in a sample, suppose carbon dioxide is 36 gram, right? Contains 36 gram of carbon, suppose, right? Okay, suppose you are having 36 gram of carbon, right? Then it is compulsory that the sample should have 96 gram of oxygen. Is that clear? Right? So they are combining in the ratio 3:8, right? So law of constant proportion says that any chemical substance or compound, the element are always present in a definite proportion. If this proportion get changed, compound will change. That would be a different compound. Is that clear? So they always combine in some definite proportion by mass. And this is called law of constant proportion or law of definite proportion. Is that clear? So please write down. Okay. So means any chemical compound is always made up of the same elements combined together in the same fixed proportion or ratio by mass. Okay. So if there is some water, right? As I explained, just explained you. So just write down example, water, right? Okay, so whenever you are getting getting water from any source, either river or rain or tap, right, or from any country, right, it is always made up of the same elements, right? And what is it is made up of which elements? H2O. It is made up of the elements hydrogen and oxygen. Yes or no? Right? So you can take this sample from anywhere, right? Okay, but it will be made up of the same elements, that is hydrogen and oxygen, in the same fixed proportion, right? And what is that proportion for water? So the fixed proportion is 1:8. Okay, right? Is that clear? So 1 gram, what does it mean? Means 1 gram of hydrogen combines with 8 gram of oxygen to get 9 gram of water. Okay, so this is the fixed proportion by mass, right? And it will remain same every time, right? Similarly, if we take the example of carbon dioxide, right? CO2, right? Okay, so we can prepare carbon dioxide from many methods, right? By burning charcoal in air, right? C plus O2, CO2, right? By heating limestone, CaCO3 gives CaO and CO2, right? Okay, calcium oxide and carbon dioxide, right? By heating sodium bicarbonate to NaHCO3, Na2CO3 plus H2O plus CO2, right? So in all these cases, you can see the carbon dioxide is formed, right? So in each case, whenever you are getting the carbon dioxide is formed, it is found to be made up of the same elements, right? And what are the elements of carbon dioxide? Elements of carbon dioxide are carbon and oxygen, right? And every time they will be same. Okay, that is carbon and oxygen. They combine together and they are combining with the same ratio in the fixed ratio. And what is that ratio? The fixed ratio is 3:8 by mass. Okay, so what is the mass of carbon? What is the mass of carbon? 12. And what is the mass of oxygen? Tell me, mass of oxygen. So mass of oxygen is 16, right? Since we have two atoms of oxygen here, so total mass will be 2 into 16, right? That means what is the proportion in which they are combining? 12 is to 32, right? Okay. And you can also write this in the simplest form of the ratio, that is 3:8, right? So carbon dioxide, in this you have how it is formed. One carbon molecule is combined with two oxygen atoms, right? Okay. So what is the atomic mass of carbon? It is 12. Atomic mass of oxygen is 16, right? Okay. So how you will get the atomic mass of this? So it is 12 is to 2 into 16. That is 12 is to 32 and 3:8, right? So they will combine in the same proportion every time. Is that clear? Getting it? Right? Similarly, water, you can also find with water. What is the atomic mass of hydrogen? Atomic mass of hydrogen? Tell me. Atomic mass of hydrogen is 1 and atomic mass of oxygen is 16. Are you getting that? Right? So for H2O, you are having two hydrogen atoms combined with one oxygen atom, right? Okay. So 2 into 1 hydrogen is to 16. Means 2 is to 16. In the simplest form, 1 is to 8. Right? So that's how we are getting the fixed proportion of hydrogen and oxygen in which they react to form, in which they recombine to form water. And every time it will be same. Is that clear? So if you are having 9 gram of water, right, and you are separating hydrogen and oxygen from it, so 1 gram of hydrogen you will get, and 8 gram of oxygen. Is that clear? Right? So in the same way, you can find out for others, right? So I hope now you're getting this. Yes or no? Okay. So we can also find the percentage of any element in the given compound, right? So write down percentage of any element in given compound. And how we can find it? Percentage of an element in a given compound is percentage of element in given compound is, it is equal to mass of that element, upon mass of the compound. Okay, mass of the element upon mass of the compound divided by multiply by 100. Right? So in this way, you can find out the percentage of an element in that compound. Is that clear? So please note it down. Now look at this question based on law of conservation, law of constant proportion, right? Copper oxide was prepared by two different methods. In one case, 1.7 gram of the metal gave 2.19 gram of oxide, whereas in the second method, 1.14 gram of metal gave 1.43 gram of oxide. Now show that the given data illustrates the law of constant proportion, right? So we have to find that in both the cases, the proportion is constant, right? And it is hence it is obeying the law of constant proportion, right? Now, let's suppose take case number one. In case one, okay. So what is the mass of copper? Mass of copper given is 1.75 gram, right? And what is the mass of copper oxide formed? Mass of copper oxide, it is 2.19 gram. Okay, right? So just find out the percentage of copper in the oxide, right? Let's find out percentage of copper in the oxide. That is mass of copper upon mass of copper oxide, right? Into 100, right? So we can find out the mass of copper in the copper oxide, right? So mass of copper is 1.75 gram upon mass of copper oxide is 2.19 gram into 100, right? So do this calculation, what you're getting. 1.75 divided by 2.19 is 0.79, right? 0.799 into 100. Getting it? Right? That means 79.9%. Right? So what is the percentage of copper in the oxide? For the first case, it is 79.9%. Right? Now let's find out the percentage of copper in the second case. Now in case 2. Right? Again, what is given? Mass of copper is 1.14 gram for the second one. Right? It is already given in the question. 1.14 gram of metal gives 1.43 gram of oxide. Right? So 1.14 gram of copper is there, and mass of copper oxide is 1.43 gram. Now we can find out the percentage of copper in copper oxide. That is mass of copper divided by mass of copper oxide into 100, right? So write down the values here. So 1.14 upon 1.43 into 100. Okay. Now do this calculation. 1.14 divided by 1.43 is again 0.797 something into 100. That is 79.7%. Right? So again, you can see here that percentage of copper in copper oxide is same. That is 79.7, or here also we are getting 79 point something. Right? That means what? The copper oxide prepared by any of the given method contain copper and oxygen in the same proportion by mass. Now, since percentage of copper in copper oxide is this, you can also find the percentage of oxygen in the copper oxide, right? Percentage of oxygen in copper oxide, right? If you subtract this from 100, right? So 100 minus 79.7, that is 20.3, right? So you can prepare in any of the method. If you are preparing copper oxide, the mass of copper and oxygen will be same. The percentage mass of copper and oxygen will be same, right? So hence we can say that this is following the law of constant proportion. Is that clear? So write down as percentage of copper and oxygen in copper oxide in both cases is same. Therefore, it follows or it proves the law of constant proportion. Okay, it follows the law of constant proportion by mass. Okay, so in this way, we have proved that yes, they are following this law, right? That proportion by mass will remain same. So I hope now you're getting this.